Hey, how's it going? I'm your host, Gerhard, and you're listening to Ship It, a podcast about getting your best ideas into the world and seeing what happens. We talk about code, ops, infrastructure, and the people that make it happen. Yes, we focus on the people because everything else is an implementation detail. How do you deal with the pressure of shipping faster and more features? Is shipping business value the ultimate goal? What about learning? The truth is that most of us are running too fast and loose, like trains that could derail at any moment. Slow down. Work more deliberately. Take the time to understand. Ask questions. And know that you're taking small but firm steps towards solving real user problems. I've learned so much from Justin's wisdom and experience. I can directly relate to many of the things that he talks about. Optimizing for smoothness, not speed. Focusing on consistency. Insisting to understand the real why. There's a lot more to it as these are nuanced and complex topics, but well worth your time. Big thanks to our partners Fastly, LaunchDarkly and Linode. Our bandwidth is provided by Fastly. Learn more at fastly.com. Get your feature flags powered by launchdarkly.com. And we love Linode. They keep it fast and simple. Check them out at linode.com/changelog.
What's up, shippers? This episode is brought to you by our friends at Fly. Fly lets you deploy your apps and databases close to your users. In minutes, you can run your Ruby, Go, Node, Dino, Python, or Elixir app and databases all over the world. No ops required. Fly's vision is that all apps should run close to their users. They have generous free tiers for most services, so you can easily prove to yourself and your team that the Fly platform has everything you need to run your app globally. Learn more at fly.io/changelog and check out the speed run in their excellent docs. Again, fly.io/changelog or check the show notes for links.
We are going to ship in 3, 2, 1.
So, in my career, I have been part of many teams that just sling code, or features, or business value, depending on who you talk to. But sometimes that did not feel right, just slinging code, slinging stuff. Yes, you should ship and learn quickly, very important. Constantly challenge your assumptions, very important. But there is such a thing as doing it right and fast, and doing it bad and fast. So what is that difference, Justin? What do you think?
Yeah, and that's the sort of, I've been on both sides of this conversation. As a entry-level developer, feeling like I had just an infinite amount of pressure, both from on high, wanting more things shipped faster than was physically possible, pushing constantly to just get features out the door or to get this thing delivered, where there was a failure to communicate between me and the people managing me, especially early on. I didn't know how to discuss things like software complexity or where my time was going. And to feel that pressure coming from above, feeling it, kind of like sympathetically through my peers who were feeling the same pressure and kind of pushing on one another to try to make that pain go away. And then a personal pressure on myself where I was, literally starting from a place of incompetence. And by incompetence, I mean could not independently build the thing I was being asked to build without significant help, significant research, significant learning. And I'm at a point now of, relative competence, but it's taken me 20 years to realize the software that I want to build as I build. But until I got to that point, I needed the safety of being able, psychological safety, as well as, I think the vulnerability in a social term to be able to communicate with the people around me about hey, I need time to figure this out, or it needs to be okay for me to ask a question about how this works. And so in the beginning of my career, I viewed your question of just slinging code versus getting stuff right almost entirely through the lens of the social pressures that others placed on me, that I imagined others placing on me, and that I placed on myself. And it was very difficult for me to escape that. Later in my career, as I started to move into either non-technical roles or helping teams in a way that was purely advisory, you'd see teams that even in the absence of pressure, they would still really struggle to get any kind of traction towards delivering anything. And I would talk to, very well-intended VPs of engineering or CTOs about like, how do I, without downstream pressuring people and, giving them deadlines and cracking the whip, so to speak, get the outcomes that I want. And the answer then and now seems to be like, that the autonomy needs to be met with some sort of healthy alignment, drive, engagement, excitement, positive energy around like just wanting to accomplish the thing together as a combined group. And unless those motivations are both, present and healthy and rewarded and aligned, you can really struggle, I think, as a team to find a good cadence, right? Mm-hmm. And I think there's a reason why we keep talking about words like velocity, speed, like how fast can we go? And, I think to somebody who's new, they might think that that's all about like how fast like you can type, right? Or how fast you get features out the door. But like really, I start to think about it in terms of not speed per se, but fluidity. Like how much friction is there day to day in people's lives? And how organically are they able to take an idea, communicate it into a product feature or aspect or stakeholder concern, and then like prioritize that and get it, scheduled and worked on and delivered and shipped and into production and then validated, and so on and so forth. How smooth of a process is that versus like how fractious? And if we're going to optimize for one thing, it's probably, smoothness over speed per se. And it's difficult because it sounds like a little bit like woo, I think, to both developers who are just like want to focus on the technology and to managers who just like want their project done yesterday.
Yeah.
So I don't long-winded way to maybe not answer your question.
No, I think that was a very good one because it just showed how much complexity there is in that answer. And this is complexity that comes from experience, comes from like the real world, all the situations that you have been in personally. And I know that many can relate to you. What I can relate to the most is that velocity. It really doesn't matter how many points you deliver in a sprint. It's not about that. It's about how can you keep that consistent, not over a few weeks, over a few months, but about across years. In a couple of years, how can you consistently maintain a speed that's healthy, that you can build on top of, that complexity, when it comes, because it will always come, it doesn't affect that consistency. That is what a healthy delivery mechanism or a delivery team looks like to me. It's never about how many points. It's about month on month, year on year, can you keep that up? And if you can do that, well, the sky's the limit. I think to this, there's another thing which keeps coming very often. Going in the wrong direction, regardless of the speed, will always be wrong. So what would you say about that, about knowing where to point teams, especially the ones that have to collaborate?
Yeah, that's a great question. And I think that guiding light for me on the most successful teams that I have either been a part of or that I have witnessed has always been a shared and common, like just understanding of what their purpose was. So I was part of an organization, a consulting company, just prior to founding TestDouble. So we founded TestDouble in 2011. So it was like 2009, 2010. And they were, in that era, what was like known as like an agile software consultancy. And so they were peddling, pushing, their own kind of blend of agile engineering practices like Scrum and extreme programming. But they did an interesting thing in their sales process of really pushing business value. And so if user stories rolled up into like epics in their sales parlance and also in how they practiced and delivered would roll up into business value stories or value stories. And we would start each engagement by actually getting the whole team in a room, developers, QA, product owners, business stakeholders alike. So it wasn't behind some secret veil of like a product organization. I didn't even know that might be considered desirable in certain organizations. I was sufficiently naive to this experience. And what was great about it was we would just have an open and honest, put up on the board like, hey, executive or stakeholder or person who brought us in here to like build this thing, how is X, if delivered as conceived, going to make or save your company money? And just boil it down. And first of all, a lot of executives, it turns out, are uncomfortable being put on the spot to answer what should be a simple question such as that. But when you really sat with it and as a team forced the conversation out, and then you followed through, not just on, I don't know, like if here's a project example that we did was currently our system is so slow that sales reps who go to restaurants to sell food supplies end up just spending, multiple minutes just waiting for pages to load, and they could hit 3 or 4 more restaurants a day if it was faster. And that would result in like X dollars. And we'd follow through and be like, okay, so like, what is X? How would you measure X? How will we like assess that X has been attained after we've delivered it? And not only in the kind of initiation phases and discovery of like what the project, but like how will we in an ongoing basis track that as the primary metric for success for this project, as opposed to arbitrary story points? Right? Because like there's no way to know whether you're going in the right direction or the wrong direction if you don't have a shared understanding of like what the point of the thing that you're building is. And most software teams, they don't know what the point of the thing that they're building is. Or it's like, in this day and age, like to know it would be to not want to work on it anymore. Whether for ethical reasons or just because it's, like a lot of the stuff that gets built these days is kind of slimy. And even though in my practice at Testable, our clients, they work on fantastic and wonderful products. I think that we have sort of been couched into this default relationship where product throws, here's the features that we want and here's the things that we need. There's a disconnect at the developer level, at the like team and engineering level, where we lose sight of or aren't really bought into or aren't really included in the discussion of like, but why? And I have seen teams where developers know the answer to why. And when a product owner says, hey, here's how these comps should go. And, you click this and then you click this and then you click this. A developer who knows like what the ultimate goal is in terms of like business value or whatever the overall organizational, objective trying to be met is, can successfully have a real two-way discussion with that product person and push back or, offer alternate ideas or even find shortcuts that would make things faster. And in the absence of that, everyone just becomes an order taker. I receive these marching orders and then I go and build the thing. And I think that's how that sleight of hand is what actually I think facilitates and enables a lot of the negative externalities that we see in our industry.
This resonates with me at many different levels. I've seen a lot of what you've just said in Pivotal Labs. I've seen this in the IBM Blue's Garage. These are the things that, you're right, were the most important ones from the beginning. I like the engagements, that engagement mentality. I like the focus on business value and customer outcomes. So all that makes perfect sense. And that is a very powerful reason to do things and to ship software. And you can correlate those points to business value. That's amazing. However, I've also seen a different side of the coin where you're working on a software that gets shipped and others get to use to implement their own things, like, for example, a database or a proxy or whatever else. But it's like more technology oriented. What do you think the equivalent why and the equivalent business value is in that case?
If you're building a developer-focused tool, and this could be, a paid database like a Snowflake or something like that, or an API, or it could be open source and it could be completely free. I think it's still important to understand that when developers are your customer, they are still human. And should probably be treated much the same way as a naive, non-technical user of a software system that serves naive, non-technical users all the time. In general, I suppose to clarify your question, are you asking specifically about how this applies when the overall objective is less about making money and more about meeting somebody's unmet need with technology?
Well, I think with the software that we write, everybody's trying to make money. But I think sometimes the relationship between making money and writing the software is clearer. Such as, for example, when you write like for business-facing, customer-facing products. But if you have a software that you build that then gets used, and then you have, if you imagine services attached to that. So let's take, for example, MySQL. Let's say that you're selling MySQL and you're building MySQL. I mean, sure, you have the licenses that MySQL has, or maybe you have a service that you offer, which MySQL is part of. But then the value is less clear because you're not building the software to, as I said, sell licenses. Someone is using it part of a service to deliver value to other users. And in that case, I think the value is less clear. So do you see it differently?
I think that what you're describing could be phrased as like a different vector, where some products are just obvious. Like if I was hired as the chief product officer of a company that made branded sweatpants, and you could put like any college name on those sweatpants that you wanted. My job as a product officer would be pretty straightforward, right? Like you can already imagine what that app would look like. And so I wouldn't have to really provide a tremendous amount of detailed subject matter expertise. If my business were to be all about and be focused on, and I'm hired as chief product officer to facilitate the FDA approval of, highly regulated pharmaceuticals. Like that job sounds a lot harder, and I hope it pays a lot more, right? And so I think the same holds for kind of what you're saying in terms of like, if I'm building a database engine, that is a very, very challenging product category because it requires, and you think about like, what are the things that are in common between that and the pharmaceutical case? It's like tremendously deep subject matter expertise, probably a lot of vision, some big dream that product person can articulate, get other people on board with, and break down into smaller reducible problems. And sometimes our wires get crossed because I think developers and software people, because we're users of a lot of the stuff, we're able to dog food, that is like use the tool as we're building it to, sometimes in a bootstrap way to build the tool itself. We can sometimes underrate the value of smart, thoughtful product as it pertains to like, technical solutions that we ourselves could like very obviously see ourselves as consumers of.
I think that makes a lot of sense. And it just goes to show that sometimes the complexity in the code that you build and everything around it can make it difficult to answer that why. I mean, you should still do it. It's still very important because if developers, software engineers, however you want to call them, are detached from the why they do what they do, then how can they find all the good things that make what they build good? And how can they get excited about it? How can they be creative and innovative about their work? So I think they go hand in hand and they're very, very important.
Totally.
Okay. If you were to describe a development pace that feels sustainable and healthy to you, what would that look like?
That's a really interesting question because for me, and it might just be a function of getting older, of being around the bend a certain number of times on the cadence of different projects. I used to, especially earlier in my career, I'd feel the ups and downs that came with software development a lot more intensely early on in my career. And I got married at the beginning of my career. On Monday, say, I would grab a new feature and I would immediately feel overwhelmed. And I'd feel like I was drowning in complexity around all the stuff that I didn't know. And I would just panic. And on Monday night, I'd come home and my wife would see me in this state and she'd try to like console me, right? And then on Tuesday, I'd have had my asynchronous brain would have a chance to think about the problem, chew on it, and I'd make some kind of forward progress somehow. And I'd feel the wind at my back and I would feel hope and inspiration. I'd come home that evening and my wife would see me in a better mood. And like, she'd feel like, oh, great. Like he's better. He's over this hump. And then by Wednesday, I'd run into another blocker and I'd be in the same pit of despair again. And so like, what I noticed early on was that I'd have these really high highs and these really low lows, and enough so that other like loved ones in my life were able to kind of predict my mood based on what they'd seen from me the previous 2 or 3 days. And I say that because to answer your question, I think that I want to acknowledge and recognize that there are aspects to this work that are deep and creative and require a lot of asynchronous chewing to successfully build and see the right solution. So even if you could just to your point, sling stuff really, really fast, sometimes features are a little bit better if you just take a more deliberate pace and allow yourself an overnight. Right now I'm in a role where I'm kind of split between duties, and I found that it's actually been really nice that I have a few focused hours to work on software in the morning, and then I get racked with a whole bunch of meetings, but in the asynchronous time where I'm not explicitly thinking about it, I can come at it the next day and have it a gust of inspiration. And if you think of the stuff that you write as being not just an inevitability of percent to complete, but that the outcome actually changes based on a whole bunch of stuff that goes on in our brains that we don't really understand. Mm-hmm. I'm almost trying to, now I feel I'm almost describing some sort of acoustic singer-songwriter, and get a particular vibe going, mm-hmm. But I feel what I would want to capture on a multi-person team level is a sense of that same sort of productivity, right? You should feel challenged. You should end some days feeling like you're up against a wall, and you should have enough time to give things a little bit of space to come at them from different angles the next day. But if a feature is taking, I don't know, a week or 2 weeks, other human factors sink in, you might just feel disillusioned, right? Or disengaged or dispirited and other diswords. And so I think that there is a boundary almost on us as biological organisms that is there's probably an answer there of different spectrums for different people, for sure. But there's probably something about the cadence of just the way that our brains work, how we exist as social creatures. And that's probably where I'd start digging to get a good answer to that question, which is probably very unsatisfying for a lot of people.
This episode is brought to you by our friends at LaunchDarkly. Feature management for the modern enterprise. Power testing in production at any scale. Here's how it works. LaunchDarkly enables development teams and operation teams to deploy code at any time, even if a feature isn't ready to release to users. Wrapping code with feature flags gives you the safety to test new features and infrastructure in your production environments without impacting the wrong end users. When you're ready to release more widely, update the flag status, and the changes are made instantaneously by their real-time streaming architecture. Eliminate risk, deliver value, get started for free today at launchdarkly.com. Again, launchdarkly.com.
So I've noticed, Justin, that you had just started a Twitter poll recently. And the Twitter poll is, this is the question. Has the emergence of DevOps sped up or slowed down teams' ability to deliver software overall? That was an interesting question. I'm wondering what the responses have been so far. I know it will still go for another hour, but what made you ask that question? And what are people replying?
Yeah, because I have a not the most healthy relationship with distractions throughout the day, I have to admit I've only kind of glanced at a few of the replies. But the reason that I asked the question is because I think a lot about how the advent of sort of mainstream open source software, and that began, I think, in the mid-aughts, when, I experienced it in the Java community because what the Java vendors were selling, enterprise Java systems and stuff, were not particularly well designed or usable. And it created an opening for a lot of open source Java tools, chief among them probably Spring and the Spring family of brands, to be the first thing that a lot of people in large organizations used that was open source. And so I got down that rabbit hole. Of course, it was still incredibly hostile to actually try to contribute to these things. And if you weren't a Unix hacker who was super comfortable in mailing lists as a modality for like how to communicate with humans. Like it was not at all welcoming. But the advent of GitHub, of course, changed all that, once you got over the hump of learning Git.
So we had, you had 227 votes so far. I was one of them. And the majority, 44.5%, are saying sped up. That's what the majority thinks, and that's what I voted for as well. We may publish at the end of the poll the results in the show notes, so check them out when the episode comes out. Okay, so do you think that the DevOps, but more importantly, the automation that seems to be abundant these days, do you think the automation made things better? Or do you think it made things worse for shipping software?
So DevOps, just like so many things in open source, became a hot and trendy buzzword that was heavily marketed and associated with either products or sort of halo projects to goose recruiting at like big tech companies. And the original idea that DevOps would be like test-driven development. And if you just give developers testing, they would incorporate it into their team room. They would automate away a lot of the pain around testing and quality assurance. And then the intrinsic quality would increase at a marginal decrease in that team's ability to deliver things quickly. And in part accelerated by the fact that they no longer had other people to have to communicate requirements to so that things could be tested. And so the theory went, if we just did that with operations, we would get the same lift. And to me, I had that experience and it was called Heroku. It was the most DevOps thing that I had ever used in my entire life was being able to say git push Heroku, not have to think about my operations at all, but know that it was taken care of, that I had answers to every question about scale and about adding on, additional components without necessarily having to turn it into my side hustle or my day job or my identity. Mm-hmm. But DevOps as a term has changed as I think the agile era of the aughts sort of undervalued and played down the importance of operations as a practice. I think a lot of the people who are, the Linux sysadmin archetype of the late 90s might be seen as sort of getting their comeuppance now or their day in the sun of lots and lots of new innovations in technology that are focused on meeting the same kind of just core desires. Some of it's like, hey, how big can we make things? How fast can we make these? How can we automate all of these, very fancy and cool, but maybe a little arcane and unnecessary at small volumes and scales, like orchestration of lots and lots of real and virtual systems up in the cloud, right? DevOps and automation tools have enabled and empowered lots and lots of really cool stuff. And my experience, right, of I just want to be able to get push Heroku and have my app work in the cloud and not have to worry about it ever again is, I think, still the pinnacle of what I would want as a developer. And of developers that I talk to that have had that experience in real life, they all wish that we could still have that, right? And Heroku still exists and it's still a thing and love the people there and I love the product, but it's not the flavor of answer that the market is searching for because everyone thinks that they're going to need Google scale and Facebook scale kind of tools for the job that's in front of their, very straightforward CRUD app with very few users. And this is all of a piece with sort of startup culture that everything needs to be $1 billion unicorn to be valuable. And so you have to presume the conclusion that, of course, you're going to reach that scale. So then you may as well just on day one reinvent the universe in AWS through all this automation. And so DevOps as a overall meme in the industry, I think, has been net negative and slowed down a lot of teams by way of distracting them, where, the fact that teams now have to hire a certain number of DevOps people, quote unquote, to full-time just keep the hamster wheels spinning of their cloud-based computing, whereas before you might even have had an on-premises server that was just sort of sitting there and was just on and worked. That's what in spite of the poll results, I think 44% of the people saying sped up, I think some percentage of those people are just people who really geek out about DevOps technologies and kind of don't care and are just team pro DevOps. And some percentage are just people who living in the ideology that we live in and probably just never had the experience of what if you could just set it and forget it and not have to worry about it again? Because if it's a means to an end, why would you want the thing that required a ton of effort and thought and complexity and specialized skills and so forth and constantly having to read up? So, I'm coming across as pretty anti-DevOps here, but I think that if you look at the replies, the number one point of contention is that no one has a shared understanding of like what we mean by the word DevOps. And so to focus on automation here, it's like, yes, I love real automation, but like, I don't think that what we're typically describing around DevOps related activities is like actually automating anything in terms of actually automating away a problem.
This specific question is something that I'm really passionate about because I am in the DevOps camp, but for other reasons. So it's not about the technology. I mean, there's some aspect of that just to see how things are changing and how they're improving. But I understand it at a very fundamental level since I have been involved with it for, as you mentioned, in your case, 20 years. But my focus has been infrastructure. And I live and breathe it on every single team. I went into the puppets, into the CF engines, into the chefs, into all those like infrastructure as code and configuration management and so on and so forth. One thing which I would like to say, the first thing is that Git push is the pinnacle. You're right. And that should not change. Changelog.com, the setup itself, has always been Git push. We used Ansible, we used Docker, we're on Kubernetes now. We'll be using something else, not before long, I'm sure of it. It has always been Git push because that is the golden developer experience. Push it and forget about it. It's all the stuff that happens afterwards that makes a resilient system in production. And I think that's where a lot of the DevOps folks or many DevOps folks forget about because they get distracted by new and shiny, or let's just keep changing things. I see a lot of parallels between test-driven development and testing and DevOps and infrastructure, where you can see things right or wrong, and the outcome will be a result of your perception, of your principles, and eventually your skill set as well. So what I can say is that if your users are happy, latency is low, all requests are going through, nothing is lost, data isn't lost, you're doing something right. And as long as developers, which by the way are also users, as long as you can just Git push and show them what is happening at all levels, whether it's testing, whether it's performance, whether it's regressions, whatever it may be, and eventually running in production, as long as they have a good understanding of how the system works as a whole, well, you've achieved your task. So you're right, Heroku had something for it, and there's many things that happen afterwards, but to be honest, not everybody cares about these things, or should they? They shouldn't really care. They should just like Git push, or just use the service and be happy. That's the end goal, to simplify it. So let's switch focus to something that I know you have a lot of experience in, which is testing. Just as a lot of advice out there about DevOps is bad, I know that a lot of the advice that's out there about testing is bad. Why is that?
Yeah, so in trying to connect the two themes, what you just shared about DevOps is 100% true and matches my experience as well. And where the analogy, I think, between the two struggles a little bit is that if I want to have that Git push Heroku experience and it costs me $30 a month, it is very difficult, I think, to be like a human who works on infrastructure and do literally any amount of customization or custom stuff and compete with that on price. But because of the way that we consider the cost of software development, like a lot of companies out there, as soon as you're a full-time employee, your marginal cost on an hourly basis is like $0. It's like they become blind to just the actual like expense of people's time. So I think of DevOps, the failures of DevOps as being a failure to recognize the time sink that a lot of teams find themselves dumping lots and lots and lots of hours into when there's commodity services that if you would only adhere to a set of conventions would get the job done close to or as well. Testing is kind of like same core fallacy in the middle, is that we talk a lot about the activity and the importance of it in a sort of Boolean state, like, are you DevOps? Are you not DevOps, right? Are you in the cloud? Are you not in the cloud? Are you tested? Are you not tested? It's sort of like the degree of sophistication, because these are secondary concerns to like building a product that does the thing that it's supposed to do. No one really has the mental and emotional bandwidth to like consider, am I DevOpsing good? Am I testing good? And so like simply like there's usually some, if not a person, like a mood in the team that's like in order for us to be a moral and ethical and upstanding team, we should be able to check this box or that box. And so I want to check the box that I'm doing DevOps. I want to check the box that I'm testing. And when we consider the bad advice about either, it's often coming from people who either are operating under that sort of simplistic notion or are, for some reason, have an incentive to enable and perpetuate it. And so what I think about the failings of either are when the team lacks an appreciation for the overall total cost of ownership, the overall return on investment of where their time's going and what are they getting for that time, or, in terms of AWS, or if you're running a bunch of servers somewhere to automate your CI build, and money. And if you appreciate that, then you can have a lot of really fun and interesting conversations about testing, right? How often are you seeing failures? When you see a failure, does it indicate an actual bug? Does it indicate, somebody forgot to update a test? Is it brittle and flaky? How long does it take to fix them? How many places do you have to fix the code or the test in order to get back to a passing build? How much time is lost in terms of waiting to run the tests locally? Do you run the tests locally? Do you run them in the cloud? And if you run them in the cloud, how long does it take until you get notified? And how many people get notified? Does the whole team get notified or just one person? And unless you know, in a quite data-driven way, the answers to a lot of these questions, general context-free advice that you see about the right way to run a test or the right tool to use is not necessarily going to help put you closer to the end goal, which is the tests serve the team to accomplish what they were trying to do, either better or faster.
That's a great one. I will have to do go back on the DevOps thought. I just can't leave it. Let's put it that way. I just can't leave it. So DevOps and automation, let's just talk about automation, is something that once you get to a certain, I wouldn't even say team size, a certain complexity, a certain maturity, you have to do. And yes, you can delegate all of that to some service provider, but knowing how the service provider works and knowing how that service provider integrates with other service providers, whether it's DNS, whether it's certificates, whether it's backups, whether it's migrations, for example, whether it's distributed database, because they do fail. All these systems fail in weird and wonderful ways. What about your CI system? Even if you use a managed service, every single one of them, in my experience, have small quirks. So having that operational knowledge of how these things work and how they integrate and what happens between your Git push and the code actually ending in production, and what happens between patching all the stuff that needs to be out there, and maybe it's just your code dependencies. But what does all that automation around the code look like to actually get the value continuously out there? And when something is wrong, detect it, notify it. And this is not just test, it's everything else. So this is operating your software. There's a lot of knowledge, even if you're using every single provider under the sun and you delegate, you offload all those tasks, they still combine at some point. And whether you know it or not, I don't know of a platform that does it all, because they can't. It's just too big. It's I have solved the operation of software. You can't say that, just as you can't say I've solved testing, every single type of testing for every single platform. So there's a lot of detail in how stuff runs, in how stuff gets out there, in what happens when things fail, because they do fail. How do systems degrade? So it's more of that operational knowledge that I think you have to have, and you need to automate around so that things are easy, so that things are resilient, they fail predictably. And that is the DevOps and the automation. There's a bit of SRE there that I think about, which is a lot more complex than Git push and run it somewhere. I don't want to care about it. The database or the load balancer. I don't even know that I have a load balancer. Just take care of it, Heroku. It's a bit more complicated than that because there's all those other elements that make the big picture.
There's a burden of knowledge and experience that I bring about testing, that you bring about infrastructure to each new thing that you do or team that you join. And one of the things that I think we as an industry, especially as we have created more sophisticated tools on every front, whether those are, frameworks or language ecosystems or dependencies or memes like DevOps or TDD, is that we haven't done a good job. In spite of the fact that there are indeed very good tools for getting started with a brand new thing and slinging some code and proving out a concept very fast. And there's a lot of tools for how to, with enough just time and person power, rebuild Google's infrastructure, at scale. What we fail to appreciate, I think, are the inflection points or really the step function, or what in my brain I envision as a literal cliff of what do you do when you're transitioning from small enough to be able to use a commodity service and not really care about so that you can focus on the thing that you're building versus the stage 2 or stage 3 of the rocket where after some gigantic chasm, we in your example, we can't use Heroku anymore. So we have to throw that entirely out. And now we have to reinvent the universe, while we're continuing to operate and suddenly own all of these things. And so I think about that in terms of slinging code and testing too, right? Like if you're able to build a proof of concept, get something out the door, there's no tests at all. Same would go for applying rigorous architecture and design principles to the software. And then same would go for, let's say to go faster, we build a server-side rendered traditional HTML templates with variables and stuff stored in a session or something, as opposed to a single page app that's built in JavaScript and might have a snazzier, user experience. We might have done all of those kinds of things early, shed that complexity to get out the door as fast as possible. But in each of those cases, once we reach that breaking point, if I've got a server-side rendered application, I can't just flick a switch and then remake it as a single page application. Just I can't snap my fingers and have sophisticated DevOps. Or if I have a big mess of, spaghetti code all over the place, I can't just overnight refactor that into well-formed, well-considered units of code, or write a test suite, that is going to be well paired at appropriate levels of abstraction up and down the stack in terms of everything. And appreciating that when we talk about scale, we are not talking about twisting a knob up or just getting more revenue. We're talking about very specific inflection points where you have to start caring about those deeper levels of knowledge that you're speaking about. And that's where I think there's a lot of a failure in our community and our industry to put a name to those things and to actually have patterns that are successful for helping teams navigate those transitions.
You asked me before we started recording what I hope to achieve with this podcast. That's one of the things. How do we share more of that? How do we bring those nuances out? How do we have those discussions and figure out how stuff is changing? And how do we need to adapt to those changes? What makes sense for our specific setup? Heroku make perfect sense. Kubernetes may make perfect sense. We just don't know because it's all specific. And guess what? You have to figure it out for yourself. We can help along the way, maybe simplify some of the choices or make them clearer. But at the end of the day, you have to choose and you have to combine those choices long term. It's not a one-off, continuously. And that's what makes this really challenging.
SignalWire is real-time video tech to help you create interactive video experiences previously not possible. It gives you access to broadcast quality, ultra low latency video that's proven and trusted by Amazon, Ring Doorbell, Zoom, and others. See why the future of video communication is being built on SignalWire. They have easy to deploy APIs, SDKs for the most popular programming languages, and expert support from the OGs of software-defined telecom tech. Try it today at signalwire.com and use code SHIPIT for $25 in developer credit. Just visit signalwire.com. That's signalwire.com and use code SHIPIT to receive that $25. Once again, signalwire.com, code SHIPIT.
Let's take a very specific example about what I think is a test suite gone wrong. Imagine, Justin, that you have just joined a team of 9 developers, so you're in developer number 10, and they're all working on the same monolithic code base. This team has constant test flakes, which means that the testing part of the pipeline that gets slinging code into production, it keeps failing for random reasons multiple times per day. And they keep hitting the rerun all jobs button, adjusting timeouts, adding more retries to their tests, that type of thing. First of all, what are your thoughts about this specific situation?
Yeah, well, I mean, unfortunately, it is all too common of a situation. And I think that it is challenging to write tests that are not susceptible to several specific things that contribute to what, is commonly called brittleness or flakiness, right? Like, the most important, I think, thing to understand as we're approaching this question from the outside in is, what is our goal to have this build in the first place? And the goal is probably to have some sort of confidence that things are working. And if we get one green build out of 5 and no source code changes in the process, right? Like, my confidence is not high, right? And we know this based on kind of like, intuitive experience, that if it passes one time out of 5, it means that like the system, you have proven the system can work. Mm-hmm. And you've probably also proven not that the system has some sort of like fundamental flaw and will break in production, so much as you figured out that there are environmental, timing, or ordering implications that can cause one or more of your tests to not work. And I think that the first thing that a team should consider when they are running into this problem is to get back to consistent green builds as fast as possible. Because again, if you're thinking about testing as ROI, if all 9 of those people are getting an email every single time that the build breaks, and then say 3 of those people just independently start racing to go and screw around with timeouts and stuff, that's a lot of dollars flying out of a window because of like, one little tiny thing that might, not be well understood. And that no one woke up that day and was like, I'm going to really wrangle all of the flaky stuff in our test suite, right? Like they're all trying to do something else, and this is the thing blocking them from that thing. And so like, they're not to say like they're half-hearted in their attempt to fix it, but like what they're really needing is a salve in that moment as opposed to a solution. Mm-hmm. So the first thing that I would do is I would like lock down everything. Normally I don't like freezing time in the system, right? But I'd probably start with like the common quick fixes that I can apply. Like, hey everyone, it is now 2019, August 3rd. It's a Tuesday and it's 11:33 p.m. and we're just going to lock that whole server down that way, whether we're using a test tool to do that or Unix. Hey everyone, we're also going to like no longer randomize the test order. We're going to use this particular seed that is known good, that we have seen work. Hey everyone, we're going to, change all of the directory globs that are currently in a like unspecified order in Linux. And that's why Linux builds are failing, but on our Mac where it's alpha order, like those are all passing. Like, hey, we're just going to do a sort on all of those glob requests everywhere so that like, we're just loading alphabetically, because it doesn't really matter. And we're going to like go through the half dozen or so quick hit things to just try to get to consistent build as soon as possible. And hopefully that's one person, one day of effort.
Yeah. What does a consistent build mean? So we said 1 in 5 passing, very bad, very inconsistent. What does a consistent build mean to you?
For me, the ideal and the asymptotic goal that I would have is any time that I saw a build fail, it means that something is broken in the application. And this is, by the way, like I think this is actually the popular notion that managers who are told about testing and see a build on a wall, like their intuitive notion is that if light goes red, it means that the system that they are, ostensibly paying to have built is currently in a state where it does not work. Right? That's intuitive. But if you're like this team has become habituated to this environment where things just break randomly, those developers will have lost confidence that red means that anything is broken at all.
Yes.
The business person is still thinking like, wow, there's a lot of failures. And so like it's time well spent to go and fix those brokenness, because like in their mind, in the business person's mind, like any time spent fixing the build is time spent making my system work when it didn't work. And so that seems valuable. But if you were to tell them that like 95% of the reds in the build that were distracting the whole team were just like bullshit implementation problems in the way that we wrote tests, because like data gets polluted from one test to the other test, depending on all sorts of different things, like that business owner would probably like, be rather upset, right?
Yeah.
And we should be the same kind of upset, right? So like the flakiness is one thing. I would only want my test to fail if something was actually broken. And I would go a step further and say, I only want my build to fail if the production code doesn't work. So if a test was just somebody forgot to update the test Like, I don't want to see that in the build. I want people to run tests locally. And if they're not running tests locally, I'd want to figure out why. And then I want to make it fast enough so that people do that. And they have the tools to like want to do that. And so that's the best answer I have to your question.
Yeah. What about, so there's a follow-up, which I think it complicates things and it makes them more real as well. What about a test suite that has to rely on integration tests because the software that you test is really complex and you have to do black box testing because a lot of the stuff, like you're testing the correctness of the system at scale. So how does the system break, for example, when we expect it to break? So that's one aspect. The other aspect is not everyone can run it locally because the stuff that the system has to provision, set up, is too big. It won't fit on a development machine. It needs multiple machines just like to basically orchestrate the system as a whole. That may be an over-reliance on integration tests, but this type of knowledge to go to something like TLA+, spec-based testing, and there's another one which I'm blanking now. It's not feature-based testing, property-based testing. To do that type of testing, it requires a special type of knowledge and a special type of approach, especially when it comes to like a heavy data system. So there's that aspect, but the other one is around different CI systems flaking in different ways. So the same test runs in two separate CI systems, and not the same tests fail the same way in the two different CI systems. There's nothing wrong with the tests. There may be a timing issue, but more importantly, it's a resource contention issue. So what would you do in that case? Because it's not the order of anything. It's not like the globbing stuff. It's nothing that you can do like the simple fixes. It's just like the sheer scale of the thing. And maybe a lot of approaches over the years, which maybe weren't as good. So you think this is like a mature code base, like a decade plus, which tends to happen, which happens to be a lot of the software, which gets more complex, more brittle, more, you just have to tend to it.
There's another aspect to what we were discussing earlier about this sort of like Boolean mindset that people have. Is it tested? Is it not? And one of the things that ideology has led most teams, at least the majority that I run into, to conclude is that there is a single bucket for every app called test. And you just put tests in it. And it's, you're lucky if it has directories that are nested underneath there in terms of organizing the tests. And there is a default sort of assumption, even on like, I would say highly competent teams, you might be able to expect that there are unit tests that will indeed run locally of most things that are added. And there might be like one integration test that maybe, will run the whole application and just prove that the feature works. If you added widgets to an existing application, maybe you would expect that integration test to create a widget, read some widgets, update a widget, and delete a widget, right? And just again, do that CRUD flow for n times for n features over the life of the system. And there's two things that make tests very, very expensive to run that you hit on. One, on the first bit, is this logical organization failure on our parts. So what I would say is like, okay, like let's say that you're building a system that interacts with early client of ours, interacts with the paging network on electrical grids to communicate to thermostats to make them go up and down when it's really hot outside in Texas. Like we could, if we wanted to, write every single test with the assumption that a thermostat on a breadboard with this serial number is plugged in and powered on this network so that we can like actually interface with it through every test, even the tests that have nothing to do with that particular integration. Even if our architecture could be built in such a way that we could just sort of like have a driver to that thing that we could easily mock out and like get away from that. Like, but if we walk into the assumption that like we need a maximally real test, every single thing this system does, we need to be able to prove scientifically that like we're going to be able to go completely end to end. Like if that's your orientation, whether explicitly like you're buying into it or implicitly like, I don't know, we've got a test directory and every test just needs, like, at least one test needs to talk to this thermostat, so we just have to assume that they all do. Like that is a failure to organize based on the constraints that you're under. And so what I would encourage people to do is have multiple test suites, and work backwards. So like what's the most resource contented environment that you might have? Maybe it's spinning up 100 different servers and so forth that are operating under a particular scale. Like great. We're going to do the bare minimum number of testing to achieve confidence there. And then we're going to, break out a new bucket where you don't have access to that and everything else will default to that until we can find another really expensive resource contendy thing to do. And then we're going to, try to increasingly make the default place where people put tests into the least integrated, least complicated, necessary infrastructure for them to work. So that's, I think, in the end of the day, like one of the answers to, I think, all these questions is you end up with some, trying to maximize the number of like isolated units that can be tested in isolation, where you get really straightforward, not only fast feedback, but the feedback tells you exactly what line the failure was on kind of tests. And some number of like locally integrated, everything's talking to everything else, but like all inside of, that mono repo. Some number of contract tests that will actually just go and like validate assertions against a running instance of some server that you integrate with. Some number of like driver style tests to that kind of thermostat. And then, maybe just a golden path, like, hey, when we turn this all on in the real infrastructure that we really have, like, can I make a user and log in? And maybe that's the only thing that you actually needed to prove in that like fully plugged together state. But then you'll sidle up to teams where they have 1,050 unit tests and you add one marginal unit test that just like makes sure that like, emails are formatted correctly. And that's running up and down the stack and not like the base time that is each individual test, like if run like logically and serially, is like 4 minutes long. And every single time you add anything, it's like this really outsized cost.
We have time for one last question, and it's going to be a quick one.
Okay.
But I'm hoping, more importantly, a fun one. I'm curious how you would describe, according to you, which is the most impressive Olympic event you've seen come out of Tokyo so far.
All right. I study Japanese language, and so the only reason I have an answer to this is because I watch the Japanese news every time I'm on my bike. And so the most impressive thing that I saw was a 13-year-old young woman from Osaka winning the gold medal in skateboarding. Mm-hmm. And to see the level of excitement that it generated, because I believe she's now the youngest gold medal winner in Japanese history, especially in a new event. So I thought that was pretty darn neat.
That's great. I was thinking something else, but maybe we drop that in the show notes because it's too funny. And I know that you could not have described that, but that's what I was hoping would happen. That's okay. It'll be in the show notes. You can check it out. This has been a pleasure, Justin. I think we need to do another one. I mean, this just got me started. There's so many more questions that I have for you. I'm looking forward to it. Thank you very much.
Absolutely. Take care. Thank you.
That's it for this episode of Ship It. Thank you for tuning in. We have a bunch of podcasts for developers at Changelog that you should check out. Subscribe to the master feed at changelog.com/master to get everything we ship. I want to personally invite you to join your fellow changeloggers at changelog.com/community. It's free to join and stay. Leaving, on the other hand, will cost you some happiness credits. Come hang with us in Slack. There are no imposters. Everyone is welcome. Huge thanks again to our partners, Fastly, LaunchDarkly, and Linode. Also, thanks to Breakmaster Cylinder for making all our awesome beats. That's it for this week. See you next week.